Hello and welcome once again. This is day one of Just Start Programming, creating console or terminal apps using Rust programming and Ratatouille. So today I'm starting a new series where I wanted to learn how to build terminal apps or console apps in Rust using a crate library called Ratatouille. As usual, we will start setting things up and then go through the documentation and try things out. So this is not a tutorial. This is my learning journey and I hope your learning journey as well. So expect problems and searching for solutions. In my first series, which is Learning Rust, the sound was not in sync on my first day streaming, as I am also learning how to set up my live streaming. We all have to start from somewhere, right? Yeah, so if you're a beginner like me, that's totally fine. I'm sure you'll pick up some skills along the way. So my advice is don't be scared, be open-minded, and just start programming. This is as realistic as it gets. So join me once again live in one take. No shortcuts, no secrets. So let's just start programming. All right, so here we are. Welcome once again. So I was researching a little bit on um, how to build this terminal user interfaces in Rust, and this is going to be a good exercise for us as well while we're learning Rust. Then I found out this uh, website called ratatouille.rs. So today we'll explore this together and see how far we can go for today's session. Alright, so Ratatouille, getting started. Let's start with the installation. So it's a standard Rust crate and can be installed. Okay, so here cargo add Ratatouille. These are the first steps. Yeah, so maybe let's create a new project. Project cd rust. And then let's create a new directory here. Series 2. Okay, then let's do a cargo new. How should we call this? Maybe first Ratatouille. Right, so let's get into this directory. And we add Ratatouille, so cargo add Ratatouille. And then let's open up Visual Studio Code. All right, so it seems like we are using Ratatouille 0.29. We can check that from cargo.toml file here. Okay. Additionally, you can use the all widgets feature, which enables additional widgets. All widgets. All widgets. Or by adding the following to your cargo toml file. Okay, so maybe we can copy this part. Let's edit cargo.toml. So 29, so let's change this to 9. Oops. Let's run it once again. Okay, so that is done. That's the first step. Okay, by default, Ratatouille enables cross-term feature, but it's possible to alternatively use termion or termwiz instead. By enabling the appropriate feature and disabling the default features, see backend for more information. Termion. What is this termion? Maybe we can search it. Termion. Termion is a pure Rust bindless library for low-level handling, manipulating, and reading information about terminals. Pure Rust. Or in your cargo toml, you can do something like this. Or for termwiz, features termwiz. What does it do? What's the difference? Termion and termwiz. Termwiz. Terminal wizardry. This is a Rust crate that provides a number of support functions for applications interested in either displaying data to a terminal or in building a terminal emulator. Do we need this? Okay, so let's say we won't be using this. Let's see how it goes, if it works or not. Okay, it says here before Ratatouille 0.27, it was necessary to import backend crate that match the backend features. Okay, in 0.27, Ratatouille now exports the backend crates at the root to make it easier to ensure a matching version of the backend crate is used. Okay, so maybe we don't need this anymore. Okay, let's move on. Feature flags. As Ratatouille grows and evolves, this list may change. So make sure to check the main repo if you're unsure. And selection. For most crates, the default cross-term backend is the correct choice. See backends for more information. Let's take a look. Ratatouille interfaces with the terminal emulator through a backend. This library enables Ratatouille via the terminal type to draw styled text to the screen, manipulate the cursor, and interrogate properties of the terminal, such as the console or window size. Your application will generally use the backend directly to capture keyboard, mouse, and Windows events, and enable raw mode and the alternate screen. Okay. Rust term backend, and then the Rust term enabled by default. Each backend supports raw mode, which changes how the terminal handles input and output processing. An alternate screen, which allows it to render to a separate buffer than your shell commands use. And mouse capture, which allows your application to capture mouse events. So let's say we will just use the default, and let's see. Okay, so on this page, feature flags, all widgets. I think this is the one we did. Feature all widgets, widget calendar, Surday. Okay, what is this? Surday enables serialization and deserialization of style and color types using the Surday crate. This is useful if you want to save themes to a file. Okay, let's move on to tutorials and see. Hello Ratatouille. This tutorial takes you through the basics of creating a simple Ratatouille application that displays Hello World. Hello Ratatouille. Okay. Code for this tutorial is available. Okay, so the code is there, but let's not use the code. Let's go through the steps here. Rust C version. Install cargo generate. Ratatouille has a few templates that make it easy to get started with a new project. Oh, nice. Okay, maybe this is how we should do it. Let's close this. Let's do it again. Okay. Cargo generate. Let's create a new Rust project. Okay. Let's check our Rust version first. 1.188. Okay. So I think ours is the latest. Or maybe we should update to the latest. Rust. What was that command? Rust up. Was it Rust up? Rust up. Update. Okay, so now it's Rust 1.89. C dash version. Okay. Install cargo generate. can we call it from here, even if we don't have a project? Cargo generate is here. 299 out of 300. Almost done. Oh, finally, it's done. Okay, and then we can create a new project. Generate Ratatouille template simple. Okay. Let's put it here. Favorite Ratatouille templates not found in config, using it as a Git repository. Project name, maybe, how should we call this? Hello Ratatouille. Ah, it's here. Hello Ratatouille. Hello Ratatouille. Short description of the project. Let's press enter. Okay. New project created. Hello Ratatouille. Okay. Examine the project. Cargo generate command creates a new folder called Hello Ratatouille with a basic binary application in it. We examine the folders and files created. This will look like, okay, so to display this, actually you need to do let's see, the cd hello Ratatouille and then 3. . Okay, so we have source main rs because it's a binary project. And then you have cargo.toml, license, and readme. Okay, the cargo.toml file is filled with some default values and the necessary dependencies. So it should look something like this. Let's okay, at this point I think we can open up Visual Studio Code. And then we can close Copilot. Don't need that. Main rs. Oh, there's already a code here. And then cargo.toml. Okay, so let's compare this with the one in the document. Hello Ratatouille version 1. Example, authors, license, dependencies. So cross term 028.1, 028.1. Okay. Ratatouille 29, color ivory. So the same. Okay. They look similar. And then the generate command created a default main.rs that runs the app. Okay, so what do we have here? Okay, these are we're using the libraries: color ivory, cross term, and of course Ratatouille. And then here we have the main, returns result. Okay, so there's this init, will run the terminal, restore result. Okay, so the run is also here. Then there is this render. Where is render called? Run is here, loop, terminal draw. Render. Okay, it's here. Okay. So before Ratatouille 0.28.1, the setup of an app was quite a bit more complex. Older Ratatouille apps may have code that includes a lot of boilerplate code to set up the app. The latest version of Ratatouille has simplified this process to just calling Ratatouille init and Ratatouille restore. Ratatouille init and Ratatouille restore. Okay. Run the app. Let's build and execute the project. Run, so you can cd hello Ratatouille and cargo run. We can also do that from here if we open up terminal. Yeah, but usually this space is quite small, so why not we do it from here? We are under Hello Ratatouille now. Okay, so we can execute it. Cargo run. Oh, nice. Ratatouille simple template. Hello Ratatouille, created using Ratatouille templates. Press escape, Ctrl C or Q to stop running. Can we resize this? Oh, it's responsive as well. Very good. Let's press Q. Okay, I want to resize this a little bit and run it again. Oh. Escape. Okay. Okay, so that was easy. Anyway, that was from the template. So they have this. You should see the build output and then a TUI app with a hello world message. Hello world. Where's the hello world? Hello render widget hello world. Where's the hello world? It says hello Ratatouille. Okay, so let's inspect the code. Now we can close cargo.toml and close this, and from here so I think it added more things here than the one in the documentation. So now you have default terminal, frame, style, text, and widgets. I don't think we have it here. Oh, this one is only default terminal and frame. And then from main, color area result install. We still have the Ratatouille in it here. And then app new run terminal. Okay, so this one, you have the run function here actually. Okay, so you have terminal draw. It looks like this. Let's see. App is here. What is app? App is a struct that contains running and boolean data type. And we are implementing the app so that we can have a function. So app will have new, return self, default, and then run is here. Okay, so run, app new run. Is it similar to this? To run, you need the terminal at least. So here we have also the terminal, which is the default terminal. And then terminal, okay, so it's checking while self is running. That's the purpose of this one, running boolean. Terminal draw. Okay, so terminal draw. And then it renders render frame. Okay, so this one is a closure. Yeah, so when you see the whole pipe, that's a closure. So it's like an inline function where you have the frame. Once you get the frame, you are rendering. You call render, so we should have a render function somewhere. Here, renders the user interface. Render frame, which is mutable. Frame type. Then you have the ampersand sign. So we are borrowing frame here. Let title. Okay, so I think this is the one we saw when we ran it. Ratatouille simple template, bold. I think these are formattings. And then centered. And then after the title, you have a text. Hello Ratatouille, and then you can have a link there also. Press escape, control C or Q. Okay, but how does it know that escape will terminate the application? And then finally, frame, we are calling render widget. Do we have it here? Frame render widget. Okay, I think this is the title of the widget. Frame area. Render widget. Oh, okay. So inside the widget, you have a paragraph widget where it creates a paragraph with this text inside, and then there's a block bordered title. Then you have the title, this one, centered frame area. Okay, so this is more complex than the example here. Frame area, the important part is the frame area. So you have frame area, so you need the frame, which is a mutable reference. So frame area here, frame is also a mutable reference. And where are we getting the frame? Frame from here. Frame from draw. Frame from draw. Originally, you have it terminal draw. Render. Okay, so I think from draw, it will have, okay, inside draw, it must be passing in the frame. Yeah. In this case, yeah, it's a closure. Render, self-render frame. Okay, and then self-handle cross-term events. Okay, so handle cross-term events, I think it's just my guess. Maybe this is the one processing the escape control C or Q. Scroll down some more and see. Here. Handle cross-term events, reads the cross-term events and updates the state of app. If your application needs to perform work in between handling events, you can use the event poll function to check if there are any events available with a timeout. Okay, so what do we have here? Handle cross-term events. Match event read. Let's check handle cross-term events again. Okay, so it's just calling the function, and it uses this match, which is a control flow. Yeah, control flow based on pattern matching. So we are reading the event, and then event, what's the data type of event? Cross-term event. Okay. Then in cross-term event, you have these patterns, event key. Okay, so this is where it captures the key event. Key event if key.kind equals key event kind. Key event kind, press. Okay, so here you have the key, and then you will have this value if key.kind equals key event kind, press. Yeah, so this is how you match, how you do the pattern matching. Self on key event. On key event, and then you're passing the, okay, so the event kind is press. So when you press a key, and then key is being passed here again on this function on key event, which is here. Key is a key event, yeah, same. And we have another match here, key modifiers. Okay, so this part here is a tuple. So you are matching against two values. So okay, so this one is anything, and then key code escape or key code Q. Okay, so any key modifiers, and then for key code, escape or Q, character Q. And then you have OR here, or operator. Key modifier control. Okay, so because control C, you need to press both control. Okay, so that's the purpose of the modifier. Control C. Or there's no key modifier. So it's either control C or control capital C. It will quit. Okay, so quit is another function here. How will you quit the application? You have quit self-running equals to false. Okay, so this is from the app structure. So if it's set to false, what does it do? Okay, while self-running is true, then it will draw. Okay, so if you set it to false, then it will stop and you return okay as the result. Okay, so where's the run? It returns okay, and then it will call Ratatouille restore. Ratatouille restore, what does it do? We don't know yet. And then just return result as well to the main function. Okay, that was quite long for the first application, and I think there are so many things here that's even for beginners might be a bit difficult. Yeah, because the pattern matching here is already, I would say it's quite advanced, especially this part where you are evaluating this part, key, if key equals key event kind press. So it's a combination of all of this one. Then you have key. Okay. So yeah, so in pattern matching, I think you need to include all combinations where you have key, mouse, and resize events. So any, I think this one could be any mouse events and resizing. And then here, any events as well. Or any is the right term for it. Yeah, so it's like other than this, then it jumps to this one. Yeah, you can see it from here also. This pattern matching here is also quite complex, but essentially it's just one block of pattern. Then it's just to check all of this to execute quit. Okay, so maybe let's try modifying this a little bit. How about if we do a control Z? Yeah, control Z. Usually control C or control Z will terminate things. So what we can do here, insert type key code colon car Z, small z, and we can also include capital Z. Key code colon car C. Okay, what else can we do? Oh, there's an error. Yeah, it should be capital C key code. Okay, let's do that one for now and test it out. Cargo, okay, let's do cargo build, cargo run, control Z. Yeah, so it worked. Let's try modifying the display. So here we can do text, paragraph, new text, and maybe let's add something here. Control C, or maybe let's do a CTRL Z. I mean, this is quite easy. We're just adding to a text. Anyway, later on we'll see how we can play around with some widgets also. Cargo build. Cargo run. Okay, so text is there. Control C, Control Z. Control Z. Okay, so it worked. Okay, so let's move on. Running the app, cargo run. Okay, counter app. Oh, congratulations, you have written a hello world. Yeah, so I think that was quite complex. It's not a simple hello world. There's so many concepts here that for beginners, you need to learn a few things. Yeah. Luckily, we have the template generator. Otherwise, it's difficult to code everything like this. Or I wanted to try something. Okay, so let's try to change this part because this is the closure way of implementing it. Maybe what we can do is, what was the function here? Function render frame widget. Okay, maybe let's just copy this part for now. And then self-render. because render is already here. Let's make it render 2. Out, and here let's delete all of this. Self render 2. Render 2 frame. Okay, so render 2 frame. We can remove this. That's the error. No field render 2 on type app. No field render 2 on type app. Type app. This type app. How was it called? Terminal draw render. Okay, so where is terminal? Terminal draw render. Okay, how about we comment this out and let's change this to render. Let's make it simple so that we only get to see hello world. Still an error. Available field is running. Terminal draw. Available field is running. What is that? Quick fix. Add field to record strat. It becomes a field. Terminal draw running. Okay, wait, let's remove that because we have self here. Find value render in this code. An associated function by that name is available on self here. Terminal, okay, run terminal, terminal draw, render. Render is here. Okay, so it's not an implementation of app. Okay, so there. Hopefully this should just display hello world. Okay, let's try. Cargo. Yeah, actually we can just do a cargo run. Hello world. Yeah. Yeah, but you can. You can do that also using print line. Okay, so let's put it back again. We don't want to see just a plain hello world. Oh, which one did I comment out? Okay, so here let's uncomment this part, and then let's bring back the closure there. Let's run it once again. Cargo run. Okay, Control Z. All right. And actually in Visual Studio Code, you see a lot of additional information here, which is also quite helpful. Yeah, but sometimes can be distracting as well. So if you okay, so if you just open a VI, is that main RS here? And then just display the line numbers. You can see there are some things you cannot see from here also. So it's just a matter of preference as well. Okay, so let's continue. What else is here? Counter app. Counter app. Previous Hello Ratatouille tutorial introduced you how to create a simple terminal user interface that displayed some text and waited for user to press a key. This tutorial will cover how to handle state and some more complex interactions. You will build a counter application that allows a user to increment and decrement a value on the screen. When you're finished, the application will look like the following. Okay, nice. You have the border here. You have a value, decrement left, increment right, and quit for Q. The application will render the counter in a paragraph widget. When the user presses the left and right arrow keys, the application will increment and decrement the value of the counter. Okay, so how do we do that? Basic app. Okay, basic counter app. A full copy of the code for this page is available. Yeah, so the cheat sheet is here. Okay, but we want to try it out. Create a new project. Cargo new Ratatouille counter app. Okay, so let's copy this one. I think this time we won't be doing any what was that? Code generating the boilerplate code. Cargo new. Okay. Ratatouille counter app. Let's close this. Editor, okay, then cargo add cross term. Okay. And then if we inspect cargo.toml, it will now have the following in the dependencies section. So Ratatouille and cross term. So let's check from here, Ratatouille and cross term. Okay. Application setup. Main imports. In main.rs, add the necessary imports for Ratatouille and cross term. This will be used later in this tutorial. In the tutorials, we generally use wildcard imports to simplify the code, but you're welcome to use explicit imports if that is your preferred style. Okay, so we can copy this one. Main.rs. What's here? So we are using cross term and of course Ratatouille. We have widgets as well, block, paragraph, widget, text, symbol, style, layout, buffer, and then the default terminal. Some editors remove unused imports automatically, so if you run into errors about missing types, make sure these are in place. Double check that shared imports like stylized come from Ratatouille and not cross-term to avoid conflicts. Okay, so we still have it here. Okay, main function. Common pattern found in most Ratatouille apps is that they initialize the terminal. Run the application in a loop until the user exits the app. Restore the terminal back to its original state. The main function sets up the terminal by calling ratatouille init and ratatouille restore methods, and then creates and runs the app. Defined later. It defers propagating the return of app runs result until after the terminal is restored to ensure that any error results will be displayed to the user after the application exits. Fill out the main function. Okay, so here we can find ratatouille init, and then restore is here. Okay. So we don't have the app yet, so it will complain. Application state. The counter app needs to store a small amount of state. Counter and a flag to indicate that the application should exit. Counter will be an 8-bit unsigned int. Okay. And the exit flag can be a simple boolean. Applications that have more than one main state or mode might instead use an enum to represent this flag. Create an app struct to represent your application state. Okay, so here we have the struct. Maybe we can delete this one. Place the struct here. So the error for the app is gone. Run function is not implemented yet. Okay, so calling app default will create an app initialized with counter set to 0 and exit set to false. application main loop. Most apps have a main loop that runs until the user chooses to exit. Each iteration of the loop draws a single frame by calling terminal draw and then updates the state of the app. Create an IMPL block for the app with a new run method that will act as the application's main loop. Okay, so here it's the implementation of the struct app, and here you can find the run function. Okay, so run is similar to the hello world also, where you have terminal and then terminal draw. Oh, you have the closure here again. So draw frame. So question mark is the error handling. So if there's an error, it will just panic and stop. Then you have handle events. So I think handle events will and just like the previous app, the key press can be handled here, which in this case it's a to do. Even draw is also to do. Okay, so let's just copy this for now. Then let's put it somewhere here. Okay, so far no compilation issues. So run. Yeah, so now run. It's not complaining anymore because run is already implemented here from this struct. And then displaying the application. To render the UI, an application calls terminal draw. Terminal draw. It's the terminal draw. Yeah, terminal draw. With a closure that accepts a frame. The most important method on frame is render widget. We have render widget. Render draw. Okay, we don't have render widget yet. Which renders any type that implements the widget trait, such as paragraph, list, etc. We will implement the widget trait for the app struct so that the code related to rendering is organized in a single place. This allows us to call frame render widget with the app in the closure passed to terminal draw. First, add new implementation of widget for app block. We implement this on a reference. Okay, so yeah, a reference. That's the ampersand sign here. Reference to the app type, as the render function will not mutate any state. Will not mutate. So it will not change any state. And we want to be able to use the app after the call to draw. Okay, to be able to use the app after the call to draw. So maybe that's the reason why we have the ampersand here. The render function will create a block with a title. Okay, so it will have a title, then instruction text on the bottom and some borders. Render a paragraph widget with the application state. The value of the app's counter field inside the block. The block and paragraph will take up the entire size of the widget. Okay. So let's just copy this one and do the analysis again in the Visual Studio Code. In IMPL widget for %app. Okay. You can put it somewhere here below. Okay, so no errors so far. Yep, so we have a widget that will have render function, and here you have title. Okay, title, and then you have the this is okay. Title is a line. I think line is a widget, maybe line. Then you have another line here. You have where you okay. So this one is creating a text with some formatting. This one is creating a vector. Yeah, so this is vector macro. You have decrement, left, increment. I think these are the things you see at the bottom of the terminal, the instructions. Yeah, but how do you place the title at the top and this one somewhere below? Okay, so you have a block, you have a bordered block. Okay, so here it is, title. So title, it's centered. So probably title. This is adds a title to the block. I think by default it's at the top. By default, the titles will avoid being rendered in the corners of the block, but will align against the left or right edge of the block. If there is no border on that edge, the following demonstrates the behavior. Okay, so it will look like this without left border. Okay. Then you have title bottom. So title bottom adds title to the bottom of the block. Okay. And yep, so it will display the instructions, also centered. And then border is set to thick. Okay. So now you have a square with this information. About this one, counter text. Counter text is a text from a vector macro containing. Okay, so the first entry is a line. Then you have inside the line you have another vector macro of value into. Okay, and then the second vector item is self counter. Okay, self to counter, which is converted to a string. Okay, so probably this is the style, but counter is where counter should be in the struct. Yeah, so counter unsigned 8 is here. So it will display the value of the counter. And then you have a paragraph. Okay, so you have a block, then you have a counter, then you have a paragraph. So inside the paragraph, this is where the counter text is inserted. Then you have a formatting centered, and then you have a block where you have the title, then render. But the paragraph is added where? Okay, wait. Paragraph, it's not added anywhere here. Okay, so you have the let, and then paragraph. Why is it that paragraph doesn't have let? Okay, so I don't know, maybe that's how it is going to be combined inside render. Okay, anyway, let's try removing some items later on and see. Okay, so let's move on. So this is just the display. We haven't done anything to change the counter yet. So next, render the app as a widget. Draw. Okay, so let's copy this one. Render the app as a widget. AMPL draw. Where is draw? Okay, it's for this draw. So we can comment out to do and insert this one. Okay, so if we run this, we should be able to see something. Oh, not yet implemented. Okay, I think that's the other to do. Okay, but that one result is okay. Oh. Argument type. How do we return result? Okay, okay, it should be okay. Run, yeah. So it shows something, but we're not doing any events yet. So this one will automatically resize. Oh, I think that's the minimum. Okay, so this one we have to terminate this. Control Z, X, Control C. Oh, I cannot terminate. Ratatouille. Okay, so let's terminate this from here. Killed. All right, so let's come back. Testing the UI output. Okay, to test how Ratatouille will display the widget when render is called, you can render the app to the buffer in a test. Add the following test modules to main.rs. Okay, so yeah, we can do this, or we can skip it as well. Maybe let's skip it. We can do that later. Interactivity. Okay, so this is where we can handle events. The handle events method that you defined earlier is where the app will wait for handle any events that are provided to it from cluster. The app will wait for and handle any events. Okay. Update the handle events method that you defined earlier. Okay, app handle events. I think we had a to do there earlier, so we can just copy this part. Where's my Visual Studio Code? here. Okay. Match event read. It will not compile because we don't have a handle key event. Okay, so let's see where is handle key event. Can I copy everything? Yeah. Event read. So here you have this one again. So this becomes like a pattern. Key event dot kind. Key event kind is press. So for key press. And then you're passing this key event to handle key event. So now we need to implement handle key event. The event read function blocks until there is an event. Event read. So it will block until there is an event. If your application needs to perform other tasks than just the UI, then you should check whether there is a pending event by calling event poll with a timeout that is reasonable for your application. More about this will be covered in future chapter. Okay. Handle keyboard events. Your counter app will update the state of the app structs field based on the key that was pressed. The keyboard event has two fields of interest to this app kind. It's important to check that this equals key event kind press, as otherwise your application may see duplicate events for key down, key repeat, and key up. Okay, code. The key code represents which specific key that was pressed. Okay, so code is not mentioned yet here. And handle key event method to the app to handle the key events. Okay, so now we have another new function similar to the boilerplate code earlier. Let's see, to handle event. We're passing key event, which is a key event, and then we're checking key event code. So key code car queue self exit. Okay, so these things we haven't implemented also. Yeah. Car queue, and then left arrow key, right arrow key. Okay. Where were we? Okay, next add some methods to handle updating the application state. It's usually a good idea to define this on the app rather than just in the match statements, as it gives you an easy way to unit test the application's behavior separately to the events. Okay, so this one is inside app, not in the widgets. So exit is here, increment counter is here, decrement. Yeah, let's copy this. We're not putting it here, but instead it will be inside the app, which we can put after this function also. Okay, exit, decrement. Yeah, so this is how it looks when you decrement in Rust. This is to increment the counter. Okay, let me save this. Then Caution. Normally your applications should avoid panicking, but we're leaving an overflow bug in here so we can show how to handle errors in the next section. A real app might use saturating sub and saturating add to avoid panics like this. Yeah, so I don't know what it is. My guess is it's another function. Testing keyboard events. Splitting the keyboard event handling out to separate function like this makes it easy to test the application without having to emulate the terminal. You can write tests that pass in the keyboard events and test the effect on the application. Add test for handle key event in the test module. Okay, so yeah, so let's just copy the test. I think the other one I also need to put it here. Okay, to resolve declare type app. Let's come back to the other one. Mod test. CFG test, mod test, test. Yeah, so they need this part. Add it here. Yeah, and then this one we can delete. Cargo, what was that? Cargo test. Okay, let's do a cargo test. Cargo test. Handle key event okay, render okay. Everything passed. The finished app. Putting this all together, you should now have the following lines. Run the app, cargo run. Okay, so let's run the app and see if it increments. Clear. No, clear. Okay, cargo run. Okay, pressing left arrow key. Oop. Attempt to subtract with overflow. Ah, okay. This is what it mentioned. 0 and then we're subtracting from 0. Press right arrow key instead. Okay, 1, 2, 3, 4, 5. Then left. Then press Q. Okay. Yep. So this happened. So there was it panicked because it was subtracting 1 from 0. Okay. Conclusion: by understanding the structure and components using the simple counter application, you are set up to explore crafting more intricate terminal-based interfaces using Ratatouille. Okay, let's move on to error handling, and we call it a day. Counter app error handling. Okay, so it says here this tutorial is outdated since 28.1. Okay, so we introduced Ratatouille init and Ratatouille restore methods in Ratatouille 28.1, which automatically set up panic hooks that removes the need for the TUI module here. We will update this tutorial soon. Okay, the problem. The app you built in the previous section has an intentional error that causes the app to panic when the user presses left arrow key. Yeah, so that's the first one I pressed eventually. When the counter is already at 0, when this happens, the main function does not have a chance to restore the terminal state before it exits. Okay, the main function does not have a chance to restore the terminal state before it exits. So from here it panicked, so it didn't even reach restore. Okay. The application's default panic handler runs and displays the details messed up. This is because the raw mode stops the terminal from interpreting new lines in the usual way. The shell prompt is also rendered at the wrong place. Okay. To recover from this on macOS or Linux console, run the reset command on reset command. On a Windows console, you may need to restart the console. Reset. Is there a reset command? Reset. Oh, yeah. It's a reset command. It's my first time seeing this command also. Set up hooks. There are two ways that the Rust application can fail. The Rust book chapter on error handling explains this in better detail. Okay, yeah, so it mentions you have recoverable and unrecoverable errors. Recoverable errors such as file not found error, just want to report the problem to the user and retire operation. However, unrecoverable errors are always symptoms of bugs, trying to access a location beyond the end of an array. And so we want to immediately stop the program. One approach that makes it easy to show unhandled errors is to use the color IRE crate to augment the error reporting hooks. In a Ratatouille application that's running on the alternate screen in raw mode, it's important to restore the terminal before displaying these errors to the user. Okay, so let's try this one. Color IRE. So it should be inside Ratatouille counter app and then cargo add. So this will update the cargo.toml color IRE. Update the main function's return value to color IRE result and call the color IRE install function. You can also add an error message that helps your app user understand what to do if restoring the terminal does fail. Okay, so we include this one first at the top of the code. Come back to main. Okay, let's add it here. So you have IRE bail and what is this? Wrap error and then result. So it's not being used yet. Okay. What we have here in result. Okay, so color IRE install in main. Where's our main? This is test, main is here. So let's insert it here. Color IRE install for anything else. Okay, so this one complains. And then after the terminal, if let error TUI restore print line. So instead of Ratatouille restore, wait, TUI. Okay, I think TUI restore is the one which is obsolete. Okay, so maybe what we can do, let's try copying this part and see. Insert, Control V. Then if let, what's that? Error. Error equals no, I want that space there. Okay. If let error from Ratatouille restore, then print line. Okay. Oh, we still have some issue here. Terminal. Not terminal init. I think that is replaced by Ratatouille. Okay. Couldn't convert the error to standard IO error. Okay, so I think this one needs to change to result, just result. So it's not IO anymore. And then we have an error. Found enum result. So I think we need to change enum as well. Wait, where is that? How can we change this? Mismatch types. Expected unit type. Found result. Default run. Let's continue. Maybe the answer would be somewhere. So yeah, app result, because app result is from app default run, so the run should be modified. Okay, so here, yeah, so run should be modified to result, and here you have handle events wrap error, handle events failed. Let's copy this. So where is run? Handle events, draw, run. Okay. Handle events. Let's comment this out, and then of course we need to change this to just use result. terminal TUI. Yes, there's a slight difference there. You see from here it's TUI. But the newer version is default terminal. Okay, we still have some error here. Okay, creating a recoverable error. The tutorial needs a synthetic error to show how we can handle recoverable errors. Change handle key event to return caller IRE result. Handle key event. Okay, handle key event. Change it to caller IRE result. Where's handle key event? Yeah, this one. Key code left and right. Handle key event, event read. Here, handle key event. Oh, wait. I think I changed this part. Oh, okay. So I think it should be fine. A handle key event should return result. Okay, then here, let's put it like this. Self exit. Car queue, self exit. Why do we have an error? Okay, exit modifies its receiver in place. Error report. That was the issue. Expected enum result error report. Yeah, because it needs to return something. So, okay. Okay, it's here. Yeah. Then let's add an error that occurs when the counter is above 2. Also change both methods return types. Add a new error to the increment counter method. You can use the bail macro for this. Oh, bail macro is I think it's a new macro also. So first time seeing this macro. Okay, so in here result is also returned. So if you go to decrement counter, and then here, okay. And then this one is added. Counter overflow. So if it's 0 and you press left arrow key, Oh, wait. And this is for increment, sorry. Let's put in stop. Then space it here, and then let's put OK. There. Oh, wrong. Okay. Decrement. What? This is increment. Okay, again, mistake. Should be here. Okay. In the handle events method, add some extra information about which key caused a failure and update the return value. Handle events. Okay, so I think I've already changed it to this one. Press self handle key event, and then we need to add this one. Wrap error with. So you have another closure here to display this part. This is our handle key event. Okay, so here, okay. Is it correct? Handle key event. Handle key event. And then you have underscore this one, and it will return OK. Return OK. Terminated by comma. It's wrong. Self handle key event. Maybe it's better if we just copy this part. Okay, we still have an issue with decrement counter. What was the issue here? Decrement counter. Question mark, question mark. Okay, so now we have this, and then in the test, handle key event, test handle key events, handle key. Okay, so it's here. Where do we put this one after this line? We need to change it to color. Let's remove this one. Okay. And here, also need to change it to this one. Okay. Add test for the panic and overflow conditions. Attempt. Okay, these are new tests. So we can copy this part all the way here. Attempt to subtract with overflow. Okay. Then the key event overflow. Okay. I think there's still an issue here. What is this again? Ratatouille restore. Update the main function's return value to result. Okay, I think we have done that. Result. App result. App result. Let app result. Okay, so result and report. Reset or restore your terminal. This expression has type found enum. So it should be result. Which one should be changed? What if I will not display this part? Let's comment it out for now. So let's cheat a little bit. Okay. And let's try to run it. Cargo, let's do the cargo test first. Okay, then cargo run. Oops, cargo run. Let's press left arrow key. Okay, so it says attempt to subtract with overflow. Application panic, it crashed. Okay, so counter overflow encountered. Yeah, because we exceeded the counter from 2. What else is there? Quit. Handling panics. So attempt to subtract with overflow. I think we have seen that. And then I don't think we have seen the backtrace. Yeah. So it means we need to set this to backtrace full. So this is an environment variable. Then we do cargo run. Let's press left. Okay, then you see all the where it panicked. Okay, and then here handling errors. When the counter increases past 2. Yeah, so I think we have seen this part also. So if we enable Rust backtrace full, then we will see this full backtrace. In Rust, we're calling it backtrace. Alright, so I think that concludes today's session. So thank you for joining me today, and I hope you have learned something as well, although we cheated a little bit, mainly because of this issue here. I don't know how to resolve it yet. Maybe let's try again tomorrow and see what else we can do using Ratatouille. So here there's a JSON editor. I think this is a very useful terminal or console application as well, as we are used to seeing JSON files. So here you can create a new JSON. Yeah, so let's try this out tomorrow or the following day. And then before I finally end, let me thank my supporters. That is it. All right, thank you so much.